I'm gonna record this. All right. Does anybody have any questions from Monday? Anything you guys want to go over? Everybody's good with multiplying and dividing? Go ahead. All right. Let me see. And by the way, I don't know if I said it last class, but y'all can use calculators. All right. Yeah, there's also what is it? Tell me it.
Right, however, every fraction, mixed number with a least fraction part.
Okay.
So it, I could be like 1/5 and 5/8.
Wait, hold on. So it's the wrong thing. You said 1/5 and 5/8. What am I supposed to do with those?
Hello.
Hey, how are you? Am I doing, is there an operation in between there? Subtracting these? All right, that's actually our lesson for today. All right, so I'll hold off on that one. Any other questions? Anybody else got it? Go ahead. Okay. It was Monday. Yeah. Cause of the snow, it was online, you know. Yeah. Yeah. But it's online though. If you go on Brightspace, the recording for the class is there. So you can just rewatch it. Yeah. So we all we did was go over the syllabus and we did like a first lesson for the day. You know, that was it. Yeah, there's some stuff that's missing from there that I wasn't able to tell you, like tutoring, because it hasn't opened yet, but I'm gonna elaborate next week about that. Hmm. Anybody else? Any questions? Any questions? The homework was good? Okay, okay. All right, that's fair. That's fair. So didn't really get a chance to talk about it, but let's talk about it now, right? I'm gonna keep it simple. Let's say that I wanted to know what is the absolute value of two, right? Those bar things, that means absolute value, right? So what I'm essentially saying when I say absolute value, right? Let's imagine that in the middle, this is zero, right? And then this would be one, and this would be two. You guys remember how to do the number line, right? We went over that. So positive two, we know is right here, right? So whenever I say absolute value, I'm trying to ask you how many units away from zero is two? 2 units, right? So the absolute value of two is just two, right? Yeah.
So it would be the absolute value of 2 minus
Mhm.
11. It would be all
Yeah.
-2.
Got you. We ain't get to that yet. That's why. Yeah, that's my fault. That's my fault. Yeah. Well, that's actually in today's lesson. Yeah. But just so you guys know, this is what absolute value is. Go ahead. Hmm. Yeah. All of it. Yeah. 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 And if you couldn't do it, just try it. You know? Yeah. That's okay. That's okay. No problem. Yeah. Just get to it tonight. Yeah. All right. Mhm.
So can you explain this again? You said
Yeah.
absolute value, so these
Mhm.
marks are
Yeah.
requiring absolute value.
Mhm. So what the absolute value is asking you is whatever numbers inside of them, how many units away from zero is it? You know? So like let's say I'm not talking about two, right? Let's say I'm talking about -1, for example, right? How many units away from zero is -1? One, right? It's just 1 unit over, right? Just 1 unit over. So the answer for this is just one, right? All right. Long, yeah. How many units away from zero is -1, right? Long story short, right? Absolute value is a function that changes anything into a positive version of whatever's inside of it. So if I say what's the absolute value of negative 1 million, it's 1 million. If I say what's the absolute value of 2,000, it's 2,000. All right. Long story short. All right. But what it is actually asking was how many units away from zero is it? That's the actual meaning behind it. Yeah. All right. No other questions?
But,
All right.
you know,
Exactly. But positive. Right?
oh,
Yeah.
so even though
Mhm.
that question he just said,
Mhm.
it would still be positive, like it would be.
Right. Mhm. Yeah. All right. So now let's jump into today's lesson. All right. Yesterday was the easy stuff. This is gonna be the hard stuff for today. All right. And as I said, if anybody's bored, take out your laptop and do your homework. I get it. So we getting into adding and subtracting today. Good stuff. All right, no problem, no problem. Toot, toot, toot. So let's take a look. So we're going to be doing operations with fractions, adding and subtracting, right? So unlike multiplication and division, addition and subtraction does not follow a rule that sounds like do the operation to the top and the bottom separately. Instead, they follow a rule of a different pattern, one which we will see many times ahead. Adding and subtracting fractions requires that the fractions be of the same kind. So for example, we will have a way to understand adding 6 to 6, but adding 6 to 5ths will require that we express them as fractions of the same kind, right? Hey, no problem. All good stuff. So let me give y'all the sauce and then we're going to try a question together. All right. And every time I give you guys like a formula, a box like this, for example, right? That's all on your formula sheet. It's on your formula sheet, right? Like if you look at the announcements that I gave you, it's attached there. Right? Yeah, yeah. So basically, what I'm doing in class is I'm explaining the formula sheet to you. Like that's literally the whole class, you know? So the answer to every single question is on there. I got you. I got you. I got you. Yeah. I got you. No worries. No worries. I was here a decade ago too, so I know. Yeah, we had Blackboard back then. Yeah, 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 yeah. Yeah. So that email that you got was from Brightspace. It's the same thing that's in the email is what's on Brightspace. Yeah. Hmm.
I started working, I wasn't seeing anything.
Yeah, I got you. But you got the emails, right?
Yeah, I got the thing.
Yeah, yeah. So just don't delete the emails. Just you could do. Yeah, I have some other students where they don't have access to Brightspace because they're not on campus, right? So like they live through their emails. That's how I communicate with them.
Yeah.
Yeah.
Connected, cause
Yeah.
sometimes the
Yeah.
professors connected, they still reached out to
Yeah.
me with my regular email.
Yeah, yeah. Oh, they're good. No, I don't even know how to do that. Yeah, I'm still learning. I'm a newbie. All right, so adding and subtracting fractions, right? So to add or subtract two fractions, here's how you do it. Step one, write the two fractions using equivalent fractions if necessary with a common denominator. Step two, add or subtract the numerators while keeping the same common denominator. That's it. That's how you add fractions or subtract fractions, whatever. All right? Check out this example right here. Anybody want to try it? That's really small. So it says 3 over 4 plus 3 over 8. That's what it says on the bottom. 3 over 4 plus 3 over 8. You guys can try it if you want. Hmm. I'll give y'all a minute to try. 6 over 8? No. No. But I like the way you think though. Yeah. Oh, with the tree?
Yeah.
Yeah. I have to use the tree because I don't know my timetables. But you probably know yours, so you could just like go ahead, you know? Yeah. Yeah.
You know your time, say it quick.
I really don't. Yeah.
Yeah, he's lying. This
mean,
is style.
You know what it is? Like, you know how they say a picture says 1,000 words, so I just sent in a picture and that's it. But real talk, real talk. Look, this question here, I got. Mm-mm. But I like the way you think though. All right. So look, as three is this is 3 over 4 plus 3 over 8. I want to add them together, right? But I can't until I get the same denominator, right? So what would the same denominator be? What would be the LCD here? What is it? 8, right? So the LCD here is 8. In case you didn't see it, right? Remember last time when I took the two numbers like this and I looked at their multiples, right? Hello. So like 8 times 1 is 8, and 8 times 2 is 16, etc. Right? Remember, I told you always start with the smallest one, right? And then you could do the top one. So this is like 4 times 1 is 4, 4 times 2 is 8. As soon as you see a number that they have in common, that's the common denominator, right? So I want to make both denominators 8, right? But I have to multiply some number by them to make it into the 8. So for the first denominator, right, I had 3 over 4. What number do I have to multiply the 4 by to make it into an 8? 2, right? But I got to be fair. What I do to the bottom, I do to the top, right? What number do I have to multiply the 8 by to make it into an 8? By 1, right? But I got to be fair. What I do to the bottom, I got to do to the top, right? Then after that, little math, right? 3 times 2, what's that? Very good. See, I knew you were smart. And then 4 times 2, what's that? 8. Good, good, good. Yeah, go ahead. What is it?
No, second part.
Oh, I'm sorry. This part you mean? Yeah. You just
As well.
I got you. All right. So then 3 times 1 is 3, and 8 times 1 is? All right. So now I got the same denominator. So all I have to do is just add the numerators, right? The number on top. All right. So help me out. What's that going to be? 9. Good. Over what? Very good. That's my answer. Right. Now, if you're, huh? It can't be reduced. I can change it to a mixed number if I wanted to. Yeah, we could do that too. I know your homework might say something funny like that, like, oh, we don't want improper fractions, we want mixed numbers or something. So remember, to change this into a mixed number, this is 9 over 8, right? Well, we're gonna do 8 into 9 like this, right? Long division. So 8 goes into 9 how many times? Once, right? And then 1 times 8 is 8. And then what's 9 minus 8? 1, right? So what does that mean? Right? The number up top, that's going to be the big integer, 1, right? The remainder, right? That's going to be the number up top here. So that's going to be 1. And then whatever you divided by, that's what's going to be here. So my final answer, I know that looks a little funny. Let me do it like this so maybe it pops a little bit. Right? So this is my final answer. It's 1 and 1/8. Okay. Questions on this? All right, go ahead. I could have, yeah. But on your homework, they might have a question where they say convert it to a mixed number. This is just how to do it. Yeah. If this was a test though, 9/8, 100. I'm chill with that. Yeah. All right. But yeah, this the hardest part of the class, this one topic. Just in general, like adding and subtracting. Yeah. Oh yeah. The words you're talking about? Got you. Here you go. Good? The last topic. So it's gonna be something called hypothesis testing. So it's like the whole point of this class, how to make a decision. All right. So there's a mathematical way to calculate how to make a decision.
Right.
Yeah. Hmm. Yeah.
Yeah.
Right.
Okay.
If you want, you can make that decision a gambling decision, and then you make money off of it. I know you don't want to gamble, so that's good. Don't gamble. The whole point of this class is so that y'all don't gamble in life.
Wait, I'm sorry. Same
Mhm.
nominated or numerated number two?
This is number 2.
No,
Uh-huh.
definition.
Oh, just the numerator, the top of it. Just add or subtract the numerator and then keep the same denominator. Yeah. Yeah. How about this? Try it out. A little bit harder. A little bit harder. Mhm. Hi, how are you?
Horrible traffic.
No, I know. And that snow, yo, it'd be hard to climb over the snow. For some reason, though, campus is mad beautiful compared to the rest of the Bronx. Like I can't explain it. Like the black top is here, everything just pushed to the side. The snow doesn't even look higher over here. It looks like it's the same level, you know. Even the birds don't want to be over here. Like they didn't come over here to do nothing, you know. Yeah. So some so what happens in that scenario, right? They give you some historical fact, right? Something that they believe is true. Or it is true. Let's just say it like that, right? But you did an experiment and you don't think it's so. You think that they're wrong, right? So what we're doing is I'm going to show you like a procedure that you could use to prove that what they're saying is wrong, you know? So that mhm. And that's what the last yeah. It'll be cool, I promise. Mad simple. And you can use it on, you can do it on your calculator. Yeah. Hmm? Hmm. Go ahead.
Okay, sorry, I'm
Okay.
trying to follow.
Mhm.
I'm trying to follow what you said, so that's fine.
The same what?
For a toasty, so for it and
Okay.
seven.
Mhm.
Yeah, sure, that's fine.
Yeah. Yeah.
I answered.
Yeah. Okay, okay.
So, and then I did the,
Mhm.
and then I got 28.
28.
Ooh.
Interesting. Interesting. Okay.
Yeah, it's funny.
Okay. So I have a integer here. What's going on?
I'm thinking about PEMDAS. Don't I have to show?
We get into that. PEMDAS is important.
So I have to start the two first, or?
Um, Something like that. Start with the denominator, the number on the bottom. So I have a 2 minus the 4 over 7. Anytime I have a whole number, what can I write it over? So what would the LCD be? Very good. All right. So how do I change a 1 into a 7? Would I have to multiply it by 7, right? But what I do to the bottom, what I do to the top. What about the 7? What do I have to multiply by 7 to make a 7 into a 7? And 1, right? What I do to the bottom, what I do to the top. All right, so then that's it. 2 times 7 is 14. Good. Over 7 minus 4 times 1 is 4, right? Over 7. All right, this is the hard part. What's 14 minus 4? 10. See, y'all good. All right. Questions on this? We good? All right.
Okay, can you explain this again? I'm sorry.
All right. So whenever you have a whole number, right? Like 5, 6, whatever, right? It could be written over 1. So like the number 5 is the same thing as 5 over 1, right? In this case, we got 2, so that's the same thing as 2 over 1, right? Then you want to get the same denominator, right? Which we know is 7, right? So we multiply. Well, what number would you like it to be? Remember, I have to make both of them the same through multiplication, right? So when you said the 28, I could have used 28, right? I could have, right? But it would have given me a larger answer at the end, and then I have to reduce it, you know? This way, this reduces, excuse me. This way of doing it, finding the LCD, enables me to not have to reduce at the end. Sometimes. Sometimes. Mhm. Go ahead. Mhm. Yeah, yeah. Subtracting or adding, we have to have the same denominator. But for multiplying, dividing, just go straight across. You're good to go. Yeah. Hello. Join us. I feel like this room is okay. I thought bad about it. but I'm pleasantly surprised. This room even has a sunset to keep me awake at night. Perfect. Mhm. Yeah. I know that's only for like this month, and in April will probably be like pitch black or something. Yeah. So how about this? A little bit harder. A little bit harder. And give y'all a minute. Y'all could talk and work together, you know. You don't gotta. No, wait on me. Still want to switch? You still want to switch? Okay. Thank you. I got you. I like that. That's good. Mhm. What's your major? What do you want to do with that? Like that. I like that. Yeah. Should definitely do that. Y'all have y'all calculators be a good time to practice using them. Just saying. Mhm. Is everybody good? All right. So here's what I got. I got 5/6 minus 1/8. What's the LCD? 8? Okay. 24 sounds better. All right. So remember how we do this, right? Take both of the denominators, right? Write out a couple of their multiples, right? So 8 times 1 is 8. 8 times 2, 16. 8 times 3, what's 8 times 3 again? 24. All right, that sounds good. 6 times 1, 6. 6 times 2, 12. 6 times 3, 18, right? 6 times 4, 24, right? As soon as you get that one number that they both have in common, that's your LCD, right? So now I want to change this 6 into a 24. What do I have to multiply it by? By 4, right? What I do to the bottom, I do to top. I want to change this 8 into a 24. So what do I have to multiply it by? What is it? 3, right? What I do to the bottom, what I do to the top. After that, 5 times 4, 20 over 24 minus 1 times 3, 3 over 24. 20 minus 3, what's that, like 17 over 24? And that's it. Right? To get the same denominator, correct? Because I need both of them to be 24. So 8 times 3, 24. And then 6 times 4, 24. Yeah. All right. Questions on this? All right. Let's see what else we got. Something easy. All right. So the homework I accidentally posted last time, like that was it. The adding and subtracting. So y'all should be good with that. Let's jump into another section, which also got posted. All right. So let's go through this. Introduction. When a child learns to count, numbers only go in one direction, they get bigger. In fact, for thousands of years, civilizations rose and fell using only positive numbers. After all, numbers first arise in answer to the question, how many? How many what? How many things? The things being things which might be picked up, looked at, put on a shelf, etc., right? Negative numbers are more complicated. right? It doesn't make very much sense to say I have -5 books, right? Historically, negative numbers arose to take into account losses or debt and was undoubtedly connected to the emergence of money or coin. In this way, there is a meaning to the sentence, I have -5. It simply means that I owe $5 instead of having $5. In this context, to owe is the opposite of to have. And the negative numbers will be the opposite of the more familiar positive numbers in a way that will be made precise below. For now, let's say that every positive number has an opposite, and this opposite of a positive number will be called a negative number. All right? Make sense? All right, just giving y'all some vocabulary real quick. Right. I'm like building up to that right now. Yeah. All right. So 0 will be special. All right. In that, sorry about that. In that it is neither positive nor negative, it is neutral. And we say that 0 is its own opposite. All right. Our goal in this chapter will be to describe how to perform basic arithmetic operations, adding, subtracting, multiplying, dividing with these negative numbers. Right. So this was on your homework. So as soon as we allow negative numbers, we will need to take into account two aspects of every non-zero number. Its sign, which can either be positive or negative, and its magnitude, which is the positive numerical value. So a positive number is indicated by a plus symbol along with with the magnitude. So for example, the symbol +5 will represent the number whose sign is positive and whose magnitude is 5. A negative number is indicated by a negative symbol, right? Or a minus symbol, right? Along with the magnitude. So, for example, the symbol -5 will represent the number whose sign is negative and whose magnitude is 5. Notice that the magnitude of a non-zero number is always positive, right? Operations with sign numbers will have to take both of these aspects into account. The magnitude of a number is represented symbolically by means of the absolute value symbol, right? Those two bar things right there. So for example, we can summarize the preceding paragraph with the absolute value of 5 is equal to 5 and the absolute value of -5 is equal to 5. We have already seen that 0 is a special number, right, when it comes to signs. Hold on one second. In fact, right, the very idea of opposite that we have used to motivate the negative numbers will be defined relative to the number 0. Along with the fact that the number 0 will be neither positive or negative, we will say that 0 has a magnitude of 0. Warning, do not confuse the meaning of symbols for the sign of a number with the meaning of symbols for addition and subtraction, right? It is an unfortunate fact that history that the symbols are in fact the same, but the meanings are very different, as we will see below. All right, so let me give y'all an example. Oops, wrong thing. Give y'all an example. All right, so we just kind of introducing some terminology right now, but it's helpful. So convention, right? When a sign is not indicated for a number, it will be assumed to be positive. So for example, the symbol 5 will have the same meaning as +5, which is +5, all right? So let's talk about graphical representation and comparison of sign numbers. While there are several ways to understand negative numbers, the graphical representation of numbers on a number line is particularly helpful. Recall that a number line has three essential components. It extends infinitely from left to right. It has a special point representing 0 in the center, right? And it has a specified unit length. In this representation, positive numbers will be those numbers represented by the points to the right of 0, while negative numbers will be those numbers represented by the points to the left of 0. When we represent a sign number on a number line, the number's sign will tell us which side of 0 it will be represented, while its magnitude will tell us the distance in terms of the specified unit length, right, from the representative, right? It's some good stuff, good stuff. Not the decimal, I'm just talking about like negative numbers
Yeah.
after the point.
Right.
Let me see. Like positive numbers will be those numbers represented by the points to the right of 0. Yeah. So you remember when I did the number line, I had those slashes. That's what they mean. Like they're all positive, like positive 1, 2, 3. Yeah. So from the representative point to the point representing 0. Thinking of the magnitude as the distance from 0 corresponds to the convention that magnitudes of non-zero numbers like distances are always positive quantities. The number line representation of sign numbers also gives us an easy, also gives us an easy way, whatever, to visualize comparison of sign numbers. By comparison, we mean either less than, equal to, or greater than. Symbolically, these possible comparisons are written as this. So this is the less than symbol, right? It means less than. This is equal, right? That's equal to, and this is greater than. All right. I don't know if this helps, but back in the day, like when we used to like diss each other, we just walk up to them and be like, yo, you a loser, right? So you know like how like loser is like a L right here. So like this is less than. I don't know if that helps, you know, but that's how I remember it. Like the L is less than and the opposite is greater than. You know, and an equal to is just those two parallel lines. Yeah. So anyway, comparing positive numbers, all right? Comparing positive numbers corresponds to our standard notation of quantity. So for example, 15 is less than 27. Comparing positive numbers in decimal or fraction notation is only a little more challenging, right? In that, we first need to see them as like quantities before comparing them. So 0.043 is greater than 0.0099, right? Since 0.043 is equal to 0.0430 and 430 is greater than 99. So what they did there, they multiplied both sides by 1,000. And that's how they compared that, right? If you didn't want to do that, I'm sure you would agree with me that 4 pennies is more than 1 penny, right? That's what that means. And 3 over 11 is less than 2 over 7, right? That may not be clear right now, but what you do is you find the LCD, the same denominator, right? And then when you simplify it, you can just compare the numerators. So 3 over 11 is equal to 21 over 77, and 2 over 7 is the same as 22 over 77. And it's really easy to see that 21 is less than 22, right? All right. How about negative 10 or negative 15, right? Which one of those is bigger? So using the number line representation and comparison of positive numbers as our guide, we will translate less than as to the left of and greater than as to the right of. In this way, negative 10 is greater than negative 15. Since the point representing negative 10 is to the right of the point representing negative 15 on a number line, this reasoning can be summarized in the following guide by comparing sign numbers. Note that signs and magnitudes are both important in comparison of two sign numbers. The lesser of two positive numbers is the positive number with the lesser magnitude, right? Like when you subtract, that's what I mean, right? The lesser of one positive and one negative number is the negative number. The lesser of two negative numbers is the negative number with the higher magnitude, the most negative number, right? They're talking about when you subtract the numbers, right? So if I have a positive number minus a negative number, right? I subtract the two numbers and keep the sign of the larger number, right? If I have a negative number minus a negative number, right? The one on the right is going to become positive, subtracted, and whichever one has the highest power is going to be the remaining um, power in the answer, so to speak. All right. All right. There's like two questions about this next topic on your homework. And I'm confident you guys can do this already because this topic makes a little bit more sense. All right. So this is operations with sign numbers, addition and subtraction. How much money do you have at the end of the following situations? Think of debt as being represented by a negative number and money you have as a positive number. So you have $100, your partner hands you $250. How much money do you have? 350, right? So that's just 100 plus 250, 350, right? All right, you have $100. Your partner hands you an $80 phone bill. How much you have? All right. So that's 100 minus 80, which is 20. All right, all right. You have an $80 phone bill. Your partner hands you $250. How much you have? What is it? 170. So that's just, well, actually, let me go straight. That's negative 80 plus 250, 170, right? All right. You have an $80 phone bill. Your partner hands you a $100 electric bill. How much money you got? Negative 180, right? So that's negative 80 plus negative 100, negative 180. Questions on this? Makes sense, right? Simple stuff. Okay. So in all four scenarios, you have something your partner adds to what you have, but the way you treat the four cases is different. All right. Doo, doo, doo. All right. So the goal in this section is to arrive at rules for adding and subtracting signed numbers. Because we now have to keep track of two aspects of each number, its sign and its magnitude, the rules will be more complicated than the rules for adding and subtracting positive numbers that we learned in grade school. So adding signed numbers. Before listing the rules for addition, it gives another illustration using the graphical representation of numbers on a number line. If you had to draw a picture using the number line modeled of numbers of the familiar equation 2 plus 3 is equal to 5, perhaps the best way to do it would be as follows. First, draw an arrow starting at 0 and stretching for 2 units in the positive direction to the right, then draw another arrow starting where the first arrow ended at the point 2 and stretching for 3 units. Also, in the positive direction, the sum is represented by the points where the second arrow ends at the point representing 5. So here we go, right? So we know that 2 positive is 2 units away from 0. right? And then now I want to go 3 units away from that, right? So where am I? I'm at 5. So that's what 2 plus 3 equals 5 means, right? You start off where the first number is, right? And then you're gonna go that many units after it. And then where are you at on the number line? That's what addition is, right? So 2 plus 3, 5. Okay. And if you know that already, just do your homework. Y'all good. It's today's lesson. Right? The advantage of this graphical representation of adding is that it is very easily adapted to take into account negative numbers. We will simply draw negative numbers using arrows pointing in the negative direction, arrows pointing to the left. So for example, in this next figure is a number line representative of the sum of 4 plus -5, right? So the result indicates that 4 plus -5 is equal to -1. If you take a few minutes to draw, right, to draw a few more of the number line pictures, a few things should become clear. First, the pattern depends on whether the two numbers being added have the same sign or different signs. Depending on that, we will end up with whether adding or subtracting their magnitude. So here's an example of the conclusion, right? So I'm at 4 right here, right? We know that 4 is 4 units away from 0, so I'm at 4. And I want to add -5 to it. So I want to go -5 units to the left, right? So 1, 2, 3, 4, 5. And I'm at where? -1, right? So that's what 4 plus -5 means, right? Start off at 4 and go 5 units to the left. That's -1, all right? That's literally what subtraction is. All right. Let me put it all together real quick because I know I just dropped a whole bunch of information on y'all. Just gonna put it all together real nice and simple. Here you go. So these are your rules for adding sign numbers, right? So to add sign numbers with the same sign, right? Same sign, positive plus positive or negative plus negative, right? The sum has the same sign as the sign of the two original numbers. The sum has a magnitude, which is the sum of the magnitudes of the two original numbers, all right? So +1 plus +2 is going to give me +3, right? 3 has the same sign as the +1 and the +2. All right. The sum, right? So the sum. Let's say that I have -4 plus -1, right? So I'm going to add those two together. That's going to give me -5, right? The -5 has the same sign as the two numbers that it came from, right? The -4 and the -1. All right. Now to add sign numbers with different signs, this is important. The sum has the sign of the number with the larger magnitude of the two original numbers, right? The sum has magnitude, which is the difference of the magnitudes of the two original numbers, subtracting the smaller magnitude, excuse me, from the larger. For example, right? Let's say I had 8 plus -3, right? I'm starting off at 8, going -3 spaces to the left, I'm at 5, right? Excuse me. So 8 was a larger number. its sign was positive. So the 5, the answer for it is positive. That's it. Let me drink something while y'all try this. Try that out. My fault. Was anybody still copying? Do y'all need to see that? I'm sorry. Is this good? Oh, I got you. Got you. Okay. I wanted to write it big so that everybody could see. Okay, so that's what we're adding. What do we think? -12 plus -15. Very good. -27. Questions on this? Good. All right. Let's talk about this a little bit. The parentheses, right, in this example, are grouping symbols meant to indicate that the symbol representing the sign of the number goes with the number and are separated from the symbol representing addition. So it is mathematically bad taste to write -12 plus -15, right? We write it in parentheses to indicate that the negative is with the number. It's not a minus or a plus sign, like for addition or subtraction. Okay. Anyway, try this. A little bit harder. Mm. It says -4 plus 12. All right. What do we think? Very good. All right. Hold on a second. So I have a negative number and a positive number. So I'm going to subtract them, but keep the sign of the larger number. All right. So the 12 is larger, so that's why that is. Yeah. Right. Mhm. All right. Here's another one to try. Go ahead. If you do it. So you just contact them. I don't know if you're in any program or something like that. You can just email them and say, "Hey, I want to talk to you about my schedule," and then they can like show you what's available. Um, Navigate is the best way. You know how to use navigate? All right, we'll talk after class. I'll show you.
Terms in the finals, or you don't know what's going to be completed.
In your formula sheet and the formula sheet. Yeah. Are we good? Have it? What should I do first in this question? Hmm? That's okay.
Find commons later.
Good, good. What is it? Give me a number that both 5 and 10 goes into.
2.
No. Both of those numbers have to go into it. 10, right? So -4/5 plus 3/10. How do I change a 5 into a 10? What do I have to multiply it by? 2, right? What I do to the bottom, I got it to the top. What about the 10? What do I have to multiply that by to make it into? What I do to the bottom, do the top. So this becomes what? -8/10 plus 3/10, right? So now -8 plus 3 is, what is it? -5, right? So this is -5/10. But I can reduce this a little bit, right? Okay, so because 5 goes into 5 once, 5 goes into 10 two times. So final answer, -1/2. Questions on it? You reduce it? Okay. So 5 goes into 5 once, and 5 goes into 10 two times. That's the 1 and 2 here. Are we good? All right, let's keep moving. I got you. Let me just make this bigger real quick. So what should be clear from the above rules and examples is that addition of sign numbers is a two-step process. Excuse me. Corresponding to the two parts of sign numbers. We first establish the sign of the result, then we determine the magnitude of the results by either adding or subtracting the magnitudes depending on the signs of the original two numbers, right? Warning. Notice that these rules do not say that a negative and a negative gives you a positive, which is a famous distortion of a correct rule, right? Which you're going to see, right? In fact, the sum of negative numbers is negative, not positive, all right? So That's taking us to our next section. So subtracting sign numbers, we will not make a new list of rules for subtracting sign numbers. Instead, we will illustrate a procedure to rewrite subtraction problems as addition problems, and then rely on the same rules for adding sign numbers that we outlined in the previous section. When subtraction is first presented in grade school, it is usually described as the operation of taking away. Unfortunately, while this analogy still holds for negative numbers, it can be more confusing, right? Is it obvious to you that taking away debt has the same effect as giving you cash, right? Instead of reverting to the number line representation that gives us a clue to our rules of adding and subtracting numbers above, right? What would the number line picture look like for the subtraction of this problem? 6 minus 2 is equal to 4. All right, here it is, right? So we start off at where we are at 6, right? And then we're gonna add -2, excuse me, subtract 2 from it. So we're going 2 units to the left, and we're at 4. That's it. So subtracting +2 is represented with an arrow going from its opposite direction, taken away from the positive direction. Now compare the next figure, right, to the number line representation of the addition problem 6 plus -2 in the figure 2.4. The two pictures are identical. We have labeled them slightly differently to take into account that the second diagram depicts addition, where the first diagram depicts subtraction. These two number line diagrams reflect reflect a very important mathematical fact. All right, so here we go. So subtraction is the same as adding its opposite number, right? So to be more precise, we need to understand what the opposite means. The context of it, in the context of addition, the opposite of a number is the number with the same magnitude but opposite sign. So for example, 3 is -3, whereas the opposite of -8 is 8. To be even more precise, we will say that two numbers are opposites if their sum is 0. Notice that 3 plus -3 is equal to 0, and -8 plus 8 is equal to 0. Notation, many times it will be convenient to think of a negative sign as representing the opposite of. So the symbol -5 can be thought of interchangeably as -5 and the opposite of +5. More importantly, the symbol negative of -2, right, should be understood as the opposite of -12, right? Which is, of course, +12. We are now going to outline the procedure for subtracting sign numbers. Keep in mind that in any subtraction problems, the order of numbers matter. So for the next examples, it's not the same as 5 to 7. The mathematical sum of subtraction is not commutative. Here's a procedure for subtracting signed numbers. Rewrite the subtraction problem as the sum of the first number and the opposite of the second number. Step 2, then apply the rules for adding signed numbers in the preceding section. All right. Important note, in applying this procedure for subtracting signed numbers, it's important to emphasize the difference in meaning between the symbols. For subtraction and the symbol for negative or opposite of, most times reading the problem out loud will indicate whether the minus sign symbol represents subtraction or opposite. So for example, subtract negative 10 minus 12. What do we get? So what do we get? Any questions on this? So think of it like you're at negative 10 and then you're going negative 12 units to the left. So that'll be negative 22.
So, we do that, yeah,
Uh-huh.
the number.
Mm-hmm. Yeah, that graph can sometimes help you to understand what's going on over here. Mhm. There we go. Try this out. We good? What y'all got? I like what you think. You're not bad. Say it again? 7? Good. Hmm? Not 22, 7. So even though they said we're not supposed to do this, I like to do this. A negative and negative makes positive, right? So this is plus 8. Right? So negative 15 plus 8, negative 7. Right? Questions on this? Hmm? Two more what? Oh no, not today. Next week. Next week, yeah. Yeah. Got you. This one? Got you.
And this is gonna be on Wednesday.
Hello? If you have trouble opening Brightspace, it should be in the email too. Like every time I post your school email. Yeah, got you. Every time I post in Brightspace, it should like send you an email. But if you don't want to use it, it's another thing you could do too when you go to IT. You could tell them that, and then they can set it up so that you get your school email on your regular email.
I teach
8 o'clock,
tonight.
I think so.
Yesterday.
Hmm.
We're gonna be at the store
Yeah, you could do it here too. Yeah.
on this floor.
Next door, right?
Hmm? Yeah.
Oh,
Yeah, there's a testing office over there. They might know about it. Yeah.
okay.
You're welcome. My fault. I didn't put another one. Oops.
Wait, can you bring it down a little bit?
I got you.
This is the next.
Yeah.
Wait, so you said a negative makes a positive, right?
Right.
What we supposed to subtract to get that by -7?
So anytime the signs are different, subtract and keep the sign of the larger number.
Always subtract.
If they're different.
So, but when you
Yeah.
said a negative, sorry, but when you said a negative makes a positive, you put -15 plus 8, we're not adding. You just
Right.
want to state, speaking the sign bigger, but if the sign is not positive, that's all I'm confused.
The sign for the 8 became positive. When I combine the sign for 8 and the minus sign, that makes it positive. How I like to remember it, in order for me to write a positive sign, I need 2 strokes on my pen or my pencil, whatever, right? And over here, I have 2 strokes. So I can write positive. I don't know if that helps, but that's something that like I kind of think about, right? If I have just one single stroke, that's minus. I can't make a positive out of that. But if I have two, I could do something. Yeah. Yeah. Yeah, the same rule right here. Mhm. Yeah, I got you. Can also verify it in the calculator. Mhm.
Did you get that? Did you get this?
Mhm.
No, meaning, okay, okay.
Okay, all right. You can. Yeah,
But I just wanna know for me, like, I
Yeah.
don't want to have a talk to you.
I got you.
Wow.
So, all right, let's get philosophical.
You get what
All
I'm
right.
saying?
So,
The adding, now, like, but we didn't add it, subtract. But then you said you keep the sound big enough and the sound big enough, it's negative. So.
yeah. All right, let's get philosophical for a second then, right? So I have -15 minus -8, right? Anytime I hit you with a minus sign, I'm asking you to change whatever's coming after to its opposite, right? So I'm keeping the -15. I'm going to change that minus sign to a positive, but I'm asking you, what is the opposite of -8? +8. And then boom, -15 plus 8.
Okay.
Right? And then after that, you're at -15, you're going 8 spaces to the right, boom, that's -7. Yeah.
So you said,
Anytime I hit you with a minus sign, a negative sign, no, let me not say, yeah, minus sign, right? Anytime I hit you with a minus sign, I'm asking you to change whatever's next to it to its opposite. So if it's positive, make it negative. If it's negative, make it positive. Yeah. Yeah. I was trying to show you a shortcut. Yeah. But if you wanna keep it the philosophical way, I'm down for that too.
Yeah.
All right. So
Talk about the size.
yeah. So what you do, right? Keep the first term always, right? Anytime you see a minus sign, right? I'm asking you to change whatever follows after it into its opposite. So the opposite of -8, we say is +8, right? Opposite.
So change the sign.
Yeah. And then if you want to get even deeper than that, right? So theoretically speaking, there is no such thing as subtraction. Subtraction is a made up operation. It's only addition. Everything is addition, right? You have addition of positive numbers, you have addition of negative numbers, right? So that's another thing you could keep in mind. There's also no such thing as division either, right? There's only multiplication, right? You multiply whole numbers or you multiply in fractions. That's the truth. Mhm.
See that everything.
The shortcut for this would be when, like I said, so the shortcut is just like this. A negative and a negative becomes a positive. That's the shortcut, right? But technically speaking, anytime I say blah, 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 minus blah, 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 whatever comes after that minus sign, what is the opposite of it? Right? Yeah. If it's positive, make it negative. If it's negative, make it positive. And then change it into addition. We're always adding. Addition is for everything. Mhm. Mhm.
Be the positive, right? Then the answer will automatically be negative.
So, all right. If I had, for this problem, if I had -15, right, -8, like this, right?
Yeah.
Right. What would happen is, and this supposed to be in parentheses, right? Keep the -15, right? What's the opposite of +8?
Negative.
-8. So this becomes plus
Negative.
-8, like that. Right? So like that's just going deeper into,
Wait, hold on.
all right. Separate example, by the way, you guys. This is not that question. That's another whole question up there. And then you do the math on it and you get like, what's this, like -23 or something like that. Yeah. But you can work on this top one right here. What's 1/4 minus 5/6? Mm. All right, what do I have to do here first? Find the LCD. So what would the LCD be here? 24. Good, good. So how do I change a 4 into a 24? We're multiplying it by what? 6, right? What I do to the bottom, I do to the top. How do I change a 6 into 24 by multiplying it by what? 4. But what I do to the bottom, I do to the top. So now what does this become? 1 times 6 is 6, right? With 24 minus 5 times 4, 20/24, right? Boom. So if I keep, let's going over this again. Say I keep the 6/24, right? I want to add it to the opposite of what 20/24 is. So what is the opposite of 20/24? Remember, this means opposite. What was the opposite of that? The opposite of a positive is a, right? So then this is negative 20 over 24. Go ahead. Go ahead. Go to the next one. Yeah. Complete all of them. Just finish all the homework sets. All right. So now what is 6 over 24 plus negative 20 over 24? 6 over 24 plus negative 20 over 24. What's the answer? Over. Perfect. That's it. That's the answer. Questions on this? Good. All right.
Why did the negative sign for become negative?
So some people weren't understanding when I said 6 over 24 minus 20 over 24. So what I'm doing is I'm like going a little bit deeper. Anytime you see a minus sign, it's just telling you whatever comes after, make it the opposite and then add it to it. Add it to the previous number. Right? That's just like some fundamental theorem type thing. Right? If you understand what 6 over 24 minus 20 over 24 is, do it that way. That's fine. Yeah. Okay. So you're right. I could reduce this a little bit, right? To get the same answer as you. All right. So two goes into 14, negative 7 times, and 2 goes into 24, 12 times, right? So final answer, negative 7 over 12.
It's asking you not
Hmm.
to take it.
Mhm. To be honest with you, later on in the class, when we start actually dealing with fractions, I don't like reduction, to be honest with you. I don't like it. When you reduce a fraction, you lose information in statistics, right? But in case y'all had another math class or something, y'all should know how to reduce, you know? Yeah. If y'all in your accounting or your finance classes, they might be like, yo, reduce it, you know, and, you know. But for here, reduction like costs information, you know, information is vital. Mhm. All right. Let's get to the easy stuff now. Y'all probably seen this on the homework already. But it's the easy stuff right here, right? So this is operations with signed numbers, multiplication, division. So multiplication of whole numbers emerge as an abbreviated form of addition. So for example, 6 times 3 means 3 added to itself 6 times. But to extend this simple understanding to all kinds of numbers, we require that the commutative, associative, and distributive properties continue to hold. So it is not too hard, for example, to extend the definition of multiplication to all integers. First, multiplying a positive number by a negative number, we can reason as in the following example. We can think of 6 times negative 3 as negative 3 added to itself 6 times. So negative 3 plus negative 3 plus negative 3, etc., all the way to give us negative 18. All right. If the negative numbers appear first, this is slightly more difficult. How can we think of negative 2 times 4 as 4 added to itself negative 2 times? However, if we insist that multiplication of signed numbers should be commutative, then negative 2 times 4 must be the same as 4 times negative 2, which is negative 2 plus negative 2 plus negative 2 plus negative 2, which equals negative 8. So, what should be clear from both of these examples is that the product of a negative number and a positive number is a negative number, right? What about multiplying a negative number by a negative number? First, you should convince yourself that the opposite of a positive number is negative, and the opposite of a negative number is positive. Second, remember that two numbers are opposites if their sum is zero. So let's consider the example. -2 times -3, we will show that this number is the opposite of 2 times -3. After all, let's continue. I'll show you all the rest. We're getting deep over here now. We're getting deep. All right. Deep over here, right? So after all, -2 times -3 plus 2 times -3 is equal to 2 plus -2 times -3 by the distributive property, and 0 times -3 is 0, right? This calculation shows that -2 times -3 is the opposite of 2 times -3, but we saw above that 2 times -3 is equal to -6, so -2 times -3 is the opposite of -6. In conclusion, assuming that the distributive property is to hold, -2 times -3 is equal to +6. This example is meant to illustrate a famous but often little understood property of multiplication of sign numbers. The product of two negative numbers is a positive number. All right. So finally, a word about division of sign numbers. We saw in the context of fractions that division is the same as multiplication by the reciprocal. Keeping in mind that two numbers are reciprocal if their product is positive, the number one, right? It should not be too hard to see that the reciprocal of a sign number is also negative, and the reciprocal of a positive number is also positive. So, commercial break. We about to get this right now. Oh, here we go. Make that a little bit bigger. The purpose of sign numbers, division, will follow exactly the same rules as multiplication. This brief discussion leads to the following rules for multiplication of sign numbers. Here's the sauce right here, right? The rules for multiplying and dividing sign numbers. The product or quotient of two numbers with the same sign is positive. Same sign, positive. The product or quotient of two numbers with different signs is negative. Different signs, negative. This is for multiplying and dividing, right? In both cases, the magnitude of the product or quotient is just the product or quotient of the magnitude of the two numbers, right? So -2 times -6, +12, right? Notice how nice these rules are compared to the rules of adding sign numbers. We never have to worry about which number has a larger magnitude, and we always perform exactly the operation indicated in the problem. So let's look at a couple examples. All right. So how do I do this? This look hard. That's a calculator problem. Oh, dang. As long as none of y'all is studying nursing, y'all be good with this. All right, let's do long multiplication here. So I'm gonna show y'all my little trick for this. So I count how many, I don't, not zeros. I'm about to say the word character, Because I'm thinking about like computer language. How many numbers are there in each one? Right? The one that has the most numbers, I put that up top. And the one that has the least numbers, I put on bottom, right? So 0.004 has more numbers than 2.68, right? That's like one is four numbers, one is three numbers, right? So I like to write that one up top. This is negative 0.004 times negative 2.68. And then just go one by one throughout it, right? So let's do it. 8 times 4. What's 8 times 4? What is it? All right. So you write down the 2, write a 3 up top here. What's 8 times 0? 0, right? And then 0 plus 3 is 3, right? So write that down, all right? 8 times 0, 0. 8 times 0, 0. Imaginary 0. Now I'm up to 6. 6 times 4 is 24, right? So this is 4, right? Write the 2 up here, right? 6 times 2 is 6 times 2. Oh, wait, no, 6 times 0. Ooh, 0, right? Plus 2, 2, right? And then 6 times 0, 0, 6 times 0, 0. All right? Double imaginary 0. Now, 2 times 4 is 8. Very good, very good. 2 times 0, 0. 2 times 0, 0. 2 times 0, 0. Add this up. What I got now? You got to add this straight down. That's the hard part. What's 2 plus 0 plus 0? What's that? 2, right? All right. What's 3 plus 4 plus 0? All right, all right. I don't see nobody counting their fingers up in here. Y'all some geniuses. Oh my gosh. All right. What's 0 plus 2 plus 8? What is it? 10. All right. All right, that's a hard one. What's 1 plus 0 plus 0 plus 0? What's that? 1. All right, good, good. 0 plus 0 is? All right, 0. All right, good, good, good. All right. After you get this number, look up here. All right. How many numbers do you have after the decimal for both of them? Put them together. It's 5 numbers, right? So decimal point here, move it over 5 spaces. 1, 2, 3, 4, 5. So what's my final answer? Final answer is 0.01072. That's how you do it. Oh yeah, also a negative times a negative is a positive, so little plus sign there. There you go. Questions on this? It's the good stuff right here. All right. So we could call it a day at that. All right. This is probably the last time that I'm gonna have time after class if y'all want to chat, because I'm gonna always be running out of here to go to tutoring right after. So take advantage. I'm chilling up here next week. Yeah, yeah, yeah. I'm lying. On Monday I'll be here after class too. All right. And Thursday as well. Can I take this down? Is anybody still copying? I can take this down. I appreciate that. Yeah, it take me a while to start this recording.